Hello, 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 everybody. I hope you're all doing well. I hope you're all excited to try question number 9 if you haven't already. Question number 9 here says, a function f satisfies the equation f of x plus 1 is equal to 2f of x plus x over 3 plus 1 for all real numbers x. Suppose f of 1000 is 2011, of course, the year of the contest. Of course, that's going to make it in at some point. Find the value of f of 2011. Okay. So, the only piece of information I really have is how to go from one value of the function to the next value. And they're giving me f of 1000. I'd have to do 1011 sort of jumps to better understand this. So that's interesting. Is there anything we can do to speed up the process? I feel like f of x is probably a quadratic equation. I can't guarantee that, but I feel like that's true. I'm not seeing anything, so how about we compute f of 1001, maybe f of 1002? Maybe there's just a pattern. Who knows? So f of x plus 1, if you're confronted with something new and there's nothing that immediately strikes you as interesting or something to explore or something you've seen before, just play around with it. So f of 1001 is 2 times f of 1000. Plus 1000 all over 3 plus 1. I do have the formula, right? Yep, okay. Good formula. So that's 2 times 2011 plus 1000 all over 3 plus 1. Okay, so that's going to be 4022 plus 1000, so it'll be 5022. All over 3 plus 1. Now I can divide that, so it'll be 3 into 5022, so it'll be 16 into 48, so that leaves me with 2, 22, so that's going to be 7, and that leaves me with 1 and 2, so that's going to be 1674 plus 1, 1675. Okay, I don't like that number. It's odd that, well, not only is it odd, but it's weird that we've gone down in value. We've gone down in value. I'll compute one more, but then I'm not seeing anything worthwhile here. So 2 times this amount all over 3 plus 1001 all plus 1. So we'll have 2 times. So it's almost going back up to 5022 again. So times 2, we'll get 150, and then 0 times 2, 32, so it'll be 3350 plus 1001, 1534, and then I need to divide that by 3. So 3 goes into 42 14 times. A 1, a 5. Uh-oh. So we'll have a remainder of 1. So we'll have 1450 and 1/3 plus 1. So it'll be 1451.33 repeating. Okay, I definitely don't like that. I'm not going to be using these numbers. So not only am I not seeing a pattern, other than the numbers are decreasing rather curiously, I'm definitely not seeing a pattern, but I'm also not liking the fact that it went away from integers. So now I'm going to multiply that by 2. I'm going to have a 0.33 to carry through, and that definitely won't be divisible by 3. We'll have a 0.99 hanging around. Oh, it's going to be madness. All right, so what else can we do? Well, let's multiply by 3. Plus x, and then this becomes plus 3. Am I seeing anything to do there? Not really. Well, suppose... No, I'm not liking this at all. Not one bit. Alright, so rearranging it doesn't seem to be doing anything for me. How about I look at the formula for f of x plus 2? So that'll be 2f of x plus 1, but that's 2f of x plus x over 3 plus 1 plus, and now it'll be x plus 1 all over 3 plus 1. So what does this simplify to? 4f of x plus 2 all over 3 plus x plus 2 all over 3 plus 1. I'm changing this plus 1 to a plus 3 and putting it up on top. So that's plus 2x plus 6. And then this becomes x plus 1. And then plus 3 here. So I'll get 4 f of x plus 2x plus 6 plus 3x plus 3 plus 9 all over 9. Yes? Yes. So I can clean that up a little bit, not that I think it's going to help me much. 5x and then 9 plus 3 is 12 plus 6 is 18. So we'll have 18 over 9. Okay, so that doesn't do a thing for me. It's still 4 times f of x. Is this maybe linear? Now, it can't be linear because so our differences here was not still an integer, so it's not a linear expression. But we have 2f of x plus 1, so 2, 1 over 3. So this guy here is 4f of x plus 5x over 9 plus 2. And I suspect the next one will be, so I think f of x plus n will be 2 to the n f of x plus 3 to the n minus 2 to the n x plus n, and this will all be over 3 to the n. So this is my suspicion. I don't know if this exactly helps me. But it would mean in general we're getting smaller for the f of x's here. But we'll never go negative. Now, how could I prove this? Now, obviously this is true for n is 1 and n is 2. F of x plus n plus 1 would be 2 times this expression. We'll change this to a plus 3 to the n. plus x plus n plus 1 plus 1, and this will all be over 3. So now the 2 will come in, it'll be 2 to the n plus 1 f of x, plus 2, 3 to the n, minus 2 to the n plus 1, times x, plus 3 to the n, n, plus, now I want to bring this in, so we'll do 3 to the n, x, plus 3 to the n, n plus 1, plus 3 to the n, all over 3 to the n, and then divide that by 3, so 3 to the n plus 1. And we'll clean that up, 2 to the n plus 1 f of x. Sure. Now the 3 n x's adds up here and gives us another 3 to the n plus 1 x. And then we have 3 to the n 2n plus 2. 3 to the n's, yeah, all over 3 to the n plus 1. So, perhaps do I have the wrong formula at the very end for my n's? Except this plus 1 is on the outside, so he needs to be a plus 3 to be here, in which case then he'll actually be a 3 to the n plus 1 here. So it'll be 3n, 2n plus 4. And so that's, that becomes 3 to the n times 2 times n plus 2. And I can't exactly divide that out. I think my constant is off. Other than that, everything seems fine. So, so I have 3 to the n times whatever it is. We'll call it g of n. And then 3 to the n g of n plus 1. Now 3 to the n, n plus 1. So I need 3 to the n, I need g of n plus n plus 1 plus 3, and that needs to be equal to 3 times gn plus 1. Right? Yes. So 3gn plus 1 is equal to g of n plus n plus 4. Okay. I think I've lost sight of what's going on here. I think we're very, very close, because I think if I get this expression, then I can say, okay, then it's 2 to the whatever the difference between 2011 and 1000 is. I don't have the right constant here. I thought it went plus 1 plus 2, but it doesn't seem to be doing that. So yeah, it was 3 to the next power, and then x plus 3, and then there was the plus. Now, why was it? Oh, it's 2 to there's a 2 to the n there. So it's 2 times that amount. So 2 times n. And so we'll have 2n here plus n plus 1 plus 3. And now we'll have 3n plus 4. Still not quite going as I want it to. But I do have my 3 n's there. So I just need an extra plus 2 somewhere in here. And it's just not happening. What did I write there? So 2f of x plus x. In this case, it's not x plus 1, it's just x plus n. Because it's the previous number. And so that doesn't become an n plus 1, that becomes a 3n. So there's no plus 1 there. So I'm left with 3n plus 3. Or n plus 1 times 3 to the n plus 1. And so this does become n plus 1 there at the end. So yay, my formula works. Okay. So I did technically prove the formula, and I admit this is now taking me quite a while, but now f of x plus n, just rewrite my formula again. It's 2 to the n f of x plus 3 to the n minus 2 to the n x all over 3 to the n plus n. Okay. Formula works. Hurrah. So now I want f of 2011. So that's f of 1000, which I do know, plus 1011. So this is going to be 2 to the 1011 times 2011 minus 3 to the 1011 minus 2 to the 1011 times 1000 all over 3 to the 1011 plus 1011. So this is my answer. Is there anything I can do to clean this up? Absolutely. No, for a second there I thought those were going to cancel. So we'll have 2 to the 1011. Yes, this should be a plus sign, so it should be 2011 minus 1000. Plus 3 to the 1011 times 1000. Plus 3 to the 1011 times 1011. Just bringing this number up. Then 3 to the 1011 on the bottom. But now this is 2 to the 1011 times 1011. And now these guys can combine, so plus 3 to the 1011 times 2011, all over 3 to the 1011. So I guess we could simplify it a little bit more and say that it's 2011 plus 2 to the 2/3 1011 times 1011. Okay. So that is going to be my final answer, because I don't think I can simplify that anymore, because I have no idea what 2/3 to the 1011 is. Now, just in general, I want to take a look. Is there, based on the fact that a whole bunch of things combined, is there a nicer way to write what I've got here? What have we got? That's 3 to the n on the bottom. Because then we'd have 2 to the n f of x minus x plus 3 to the n x plus n all over 3 to the n. So in general, it should be 2 to the n over 3 to the n f of x minus x plus x plus n. And this is a better version of the formula. Probably would have been easier to prove with as well. But does this work? If I do f of 1002 here, I will have, so that's f of 1000 plus 2. So I should have 4 over 9, 2011 minus 1000, plus 1002. So that's a difference. So that should be 4 out of 9, 1011 plus 1002. We'll combine that together, and we'll say, okay, it's 4044 plus 9018 all over 9. And that will be 1304, and 8 is a 2. Carry the 1, so 6. Divide that by 9. Now I can divide that by 3. 1362 divided by 3. There's going to be a 4 there. 12, 1 down. 106 is 105, and that's 35, I believe. And so then that's 105, 1, 2, so it should be 4354 all over 3. And that, I'm pretty sure, is the number that we had earlier, 14. So 14 is 42, down goes the 5. 5 there, and then we're left with a 4. 3 goes into 4 once with 1/3 as the remainder. Hey, the formula worked. Okay. So to summarize, because I know it's been a while, our final answer, f of 2011, and there's really no better way to write this, is going to be, oh gosh, what was it? I think it's 2011 plus 2 over 3 to the 1011 times, I think it was 1011. I will go back and double check, but I'm fairly certain that's what it was. Yeah. Okay. Not bad at all. Very interesting. I wonder if, it doesn't look like there was a better way to write this. Because in the end we had exponents, we had powers there. And the whole reason I did this is because I just caught the expression. It was 2 and 1 over 3, and then the 4 and 5 over 9. I was trying to make sense of these coefficients here. Because the 18 over 9 becomes just a very quick 2, so you're left with the 4 and the 5 over 9. If I hadn't gotten the pattern, one more would have done it, because then I would have had 8 and 19 over 27. That would have made things very clear. But we learned a little bit. Very interesting little function. I liked that. Obviously, it's longer than I usually do for a question. Well, no, it's probably about the same length I usually do for question 9. So that means it was a good question 9. And it just makes me all the more excited to see what question 10 is. If you haven't already, I would stop. I'd encourage you to try question 10 on this contest. If you're looking for a copy of it, the very first link in the description will get you a copy of this 2011 paper. The 2011 Manitoba Math Contest, and try question 10 out before watching the next video. That said, have a wonderful day. Happy hunting on that question number 10, and I will see you in the next video.